Compressors have several controls which interact. The main ones are threshold, ratio, makeup gain, attack, and release. Sometimes there's also a knee control. One of the two main controls is threshold. This sets the level above which the compressor will begin reducing gain. Experienced users tend to do this by ear, but there's usually a gain reduction meter that indicates when the compressor is actually doing something, reducing gain. If you're just learning to use compression, you should keep an eye on this. It'll help you get a handle on how much compression you're applying as you adjust the controls. Some compressors even have another display that shows the signal level crossing the threshold. This graph is called a transfer function. It shows input level versus output level. No change, no compression applied, displays as a rising diagonal line. Depending on the settings, when the signal crosses the threshold level, that line will indicate the degree of gain reduction dialed up by the other controls. It's good for learning, but most compressors don't include an animated visual with this, so don't get too dependent on it. In my example from the previous tutorial, I'd want to adjust the threshold to a level that caused the medium and louder level notes to cross the threshold and be reduced in gain, but didn't affect the softer notes, the ones that are getting lost. But first I'd check the other main control, ratio. I'd make sure that the ratio setting is above 1:1, which means no effect. Around 3 or 4:1 would be a good starting point. This way, as I adjust the threshold setting, when the signal crosses the threshold, the gain reduction meter will show the gain change, and that'll help me find the right threshold setting, the one that makes the compressor affect only the notes I want it to. Once I've got an approximate threshold setting, I'll turn back to ratio. While threshold determines when gain reduction is applied, ratio sets how much gain reduction is applied when signals cross the threshold. It's always expressed as something to 1, 2:1, 3:1, etc. So a 2:1 ratio would mean that for every 2 dB the signal goes above threshold, it'll be reduced to a level only 1 dB above threshold. A 4:1 ratio would mean that for every 4 dB a signal exceeds threshold, it would be reduced to only 1 dB above threshold. That's 3 dB of gain reduction. So again, still with a 4:1 ratio, if the signal exceeds threshold by 12 dB, it would be reduced to a level 3 dB above threshold. That's 9 dB of gain reduction. As you can see, at any ratio, the more the signal level exceeds threshold, the more gain reduction is applied. Typical ratios range from 2, 3, 4:1, up to around 6:1, 8:1. By the time you hit 10:1 or 20:1, signals above threshold are being reduced so much that the level really can't go above the threshold at all. This more extreme degree of compression is called limiting. That's why you'll often see these processes referred to as compressor limiters. It's the same effect, it's just a matter of degree. Now, once you've lowered the level of the louder portions of the track, the whole performance may be too quiet. You then turn to the gain, or makeup gain control, and bring the overall level of the compressed signal back up, until the track once again blends with the mix properly. But now the quieter notes are clearly audible, and the louder ones are under control. You can see how the compression is affecting the wave in this mock-up. The louder sections get reduced in level, and then the overall level of the compressed wave is raised. With more consistent levels, the track now blends more consistently in the mix, but still has some dynamic variation in it to preserve the energy of the musical performance. If we'd applied too much compression and evened out the levels too much, we'd have lost that. Now remember, this is just one way to approach compressing a track, but it's a good way to get a handle on the process. Next up, I'll finish going over the rest of the controls.